live. We can probably begin. So, hi everyone, welcome to another ChatLoopBackOff session where a CNCF Ambassador explores a project for the first time with you. Today on episode, we are going to be talking about the project Coordinator being explored by Henrik, and I'm your host Shivai, also a fellow CHF ambassador, and I'll be here with you in the chat. So if you have any questions, feel free to ask those in the chat, and we'll definitely address them. And yeah, so let me first bring up Henrik. All right, so we have Henrik here. So Henrik, please, would love for you to share where are you joining in from, and of course, do make sure that in the chat you let us know where are you joining in from. That's always an interesting part. Like I'm joining in from India, from New Delhi, and feel free to share where you're joining in from. And of course, if you have any questions, we'll be addressing them. And do ensure that since this is a CNCF live stream, an official live stream, so please do abide by the CNCF code of conduct and be excellent to each other. And Henrik, over to you. Please introduce yourself and take it away. Thank
All
you so
right.
much.
So thanks, Shiva, for the introduction. So my name is Henrik Rexed. I'm a CNCF ambassador. I'm a client leave advocate. I also run a YouTube channel called Is It Observable? So I produce a lot of content. I've been doing a couple of ChatLoopBackOff in the past. So I'm very excited to be here again at ChatLoopBackOff because it's an amazing exercise. So to be honest, when I got the several topics and I looked at it and I said coordinator, I have no idea what it is. I want to learn about it. And then I checked the docs and I said, okay, so how am I demonstrate that? How am I going to demonstrate that? So that was my big concern. But we'll touch base together during this hour. I will try. I have prepared a repo. I have not put it on GitHub yet, but probably later on I will push it to GitHub. I may have done some mistake, so consider that. Maybe you will also be connected and discovering that project, and maybe you already have some experience about that project. So maybe you could also help me troubleshoot and make this demo working. All right. So the topic, as you understood, is about Coordinator. So here's the website, coordinator.sh. So maybe I can put this on the chat, private chat, so we can put it as a QR code or something. But Coordinator is a super interesting project. It's been initiated initially by Alibaba, the folks from Alibaba, and then donated back to CNCF. And they were basically if you look at the docs is pretty solid, to be honest. There's a lot of areas, so I looked at it here and there. But what's the purpose? All right, so what's the purpose? To explain that, for those who are aware of Kubernetes, let me at least remind Kubernetes for those who may not have that expertise. Let me go here. Okay. So I have my home lab, and for this exercise, I've prepared a cluster with 3 nodes. And if you are with Kubernetes, there's several. The control plane has a couple of components: control plane, API, etcd, scheduler. The scheduler is responsible for scheduling, and then every node gets a couple of local components, kubelet and kubeproxy. And kubelet will be in charge of measuring how our workload is behaving, and then depending on our request and limit, we will have what we call QoS, quality of services. So this is basically quality of services will help kubelet to determine if we need to evict or to do something. He will look at the quality of services that we've defined, and they are by default in Kubernetes. There are 3 of them, so guaranteed, burstable, and best effort. And what it's going to do, those are basically assigned by default by Kubernetes, depending on your request and limit. So guarantee is a request equal limit. Burstable is that request is under the limits, and best effort there's nothing. There's nothing. So depending on how you've defined your resource allocations, you will get a QoS by default, and kubelet and the scheduler will decide what to evict based on those 3 QoS. So that's on eviction side. But then you have the scheduling part. So if I have an important workload that needs to be scheduled. For example, if you have a new node, you have a daemon set, and you want to make sure that that new workload will be scheduled before anything else, then this is where we put priority class. So priority class, as you know, it's basically will uh, flag a pod as more important to the other in the scheduling, and then the scheduler is supposed to take the high priority class before and then schedule that. So that's basically what we have by default in a vanilla Kubernetes without Coordinator. So we say, okay, great, but what does Coordinator brings in? Well, Coordinated is trying to make the resource allocations more efficient. And for this, it tries to muscle up at the end what we have with the scheduler. So there's a couple of components in the scheduler, so scheduler and descheduler. So defining how to schedule and how to deschedule things. Because they made it probably they have a use case at Alibaba where they had some cluster just for LLM batch, for example, and other ones for more in front facing applications. And then at the end, they had a lot of clusters with a lot of nodes, and they try to figure out if they could have a project where they could use everything in one cluster. So then the batch, for example, the front facing application will be have a certain priority during the day and very important in terms of latency. And then if the batch that comes in the evening, then depending if there's some resource idle, he will get access to this. So this is a way of taking advantage more efficiently on the resources, and given the fact that today, if you look at how resources manage into the cluster, it's a big pain. I think 30 to 40% of the clusters are not well optimized. So Coordinator is here to help, and that's the purpose of it. So if you go back to the diagram, now that we have the standard, if you install the Coordinator, then you are you will get now, instead of having this guarantee burstable and best effort, which is delivered by the default scheduler in kubelet, then when you install a Coordinator, then what happens is, that's the wrong it will basically get you different components. So if I can basically go to my terminal if I have it here. So let me zoom in so then you can see. Here. So here it's basically in my cluster. I have already deployed Coordinator, and as you can see, there's everything. So there is the coordlet as a daemon set. There's the cores device daemon. There is the descheduler as a deployment. There is a manager and a scheduler. So everyone basically you can understand on the actual naming. So we say that the manager is like the operator that gets the request from the API server with a webhook admission controller and validation controller. You have a CRD. It will configure things automatically. And then there's the other pieces that are very important, which is the scheduler and descheduler. So scheduler at the end, if you are putting specific annotations in your workload, then you're basically delegating the scheduling to the core scheduler. So he will be in charge of that. And then the same way, if he needs to be descheduled because for some reason we need to share resources differently, then there's another deployment called the descheduler responsible for descheduling. And then you have, of course, Coordlet. So kubelet coordlet, something, which is going to be measuring the resources of the pods and taking decisions based on custom configurations. I mean, you can have auto configurations on Coordlet. We'll see that in a moment. And then you have this notion of core device. You say, what is a core device? Well, if I do kubectl get device, so it's a CRD, we can see that I have a four cluster. It's a cluster with a one control plane and 3 workers, and then you can see that every individual nodes in Coordinator is considered to be a device. And depending on how we are putting things, the device is like managing the node, the configuration. So if I have no GPU in that cluster, but if I have some specific resources or type of CPU or whatever, the device will get the details. So let's for example just describe at least. So I didn't do anything. I just installed it, and then it discovered already the nodes and populated those devices. So that device is going to be at the end. So describe. I'm typing like I don't know what's going on. Device up. All right. Whew, that was a difficult way of typing. So you can see that now. So it's part of the CRD provided. We can see that it's a controller. There's no much things so far because at the end there's I didn't put any customize QoS that, and I will come in a moment about this on what on the workload are using those custom coordinator QoS. Sorry, and then you can see we can fine tune. There's a lot of things we can do to fine tune if you want to have more CPU than that you are allowed to. So CPU burst, you can do that. So there's a couple of things that is pretty cool. And then if you look at the device, you will see things that will be watched by the device. So that's what you get. And then out of this operator, of course, if you if you do the get CRDs, we will also have a metal LB here. You can see that we have a couple of things. I'm gonna maybe don't have the time to touch base on everything, but we have the device. We looked at it. We have what we call the elastic quota. So where you can put you can dynamically allocate things with the elastic these CRDs when it's scheduled by the coordinator. You have the node metrics. Of course, you'll see that there's notion of SLO. So you can have custom QoS, and then you will define SLO. Let's say, oh, if the node is at 65%, those classes will be evicted, and then you can even define the number of the percentage of throttling that you can put in place. So it's pretty nice, in fact, to be honest. And then if I go back, let me check. So I have also the OpenTree operator installed, and here you have the recommendation and reservation. Reservation is pretty interesting. Is you let's say that you have you know that you're going to have a workload coming in with a specific container, with a specific pod, with a specific labels, blah blah blah, and then you want to block on that node or on that cluster resources for this because you know that tomorrow my team is going to deploy it, so let me reserve those stuff because it's my workload is super critical. So you have this notion of reservation. So even if my pod is not really there, we can also already pre-block the resource allocated on those devices nodes. And when you deploy the pod says, okay, it's been reserved. So then he will give the resources that you have blocked. So it's quite interesting, this notion of reservations. I think from specific use cases, it makes completely sense. Not for every type of workload, but for a couple of really critical, really big critical workload, it makes complete sense. And then you have something that you mentioned is like the notion of pod groups. I'll touch base if we have time, of course, today on that regards. So that's what we get. So if you go back to the here. So we saw that we have those scheduler, the scheduler, coordinate, device daemon, and the manager. And then at the end, what we are getting as by default here, we will get a predefined pod priority class. So let me go back. What a priority class, not pod priority class. Come on. Okay, you can see that it added 3 priorities with different numbers, with different level of importance. Yeah,
Henrik, just one quick. So sorry for interrupting in between. We got a comment saying that the text is a bit small. Could you potentially zoom in a bit more?
is it better?
Yeah, that looks
All
a
right.
lot better. Thank you.
Well, I will remove my glasses now. No, just so but when we deploy it, it gets also a priority class, and you will see that the priority class will be assigned to the QoS. Remember, by vanilla Kubernetes, you get three QoS by default, and then you can define your own priority class, but there's no link between both of them. Here, a QoS will have a priority class assigned. So depending on when you assign a specific QoS, then you know that you will have a specific priority. So you can see that there's code prod, code mid, code free, code batch, and this is going to be a link pretty much to what. Okay, I need to zoom in as well. This is going to be pretty much related to what we're going to get once we assign those QoS. So in Koordinator, there are 5 priority class. There's LSE, standing for latency sensitive exclusivity. So basically, it's a you get some resources, and they will basically get it. They will have a priority on the resource. Then, so it's the highest level of class. And then, as you understand, it will get the highest level of priority class as well. And then you have the LSR, so latency sensitive restricted. So here it's good, but you can have some resources that are if you have a LSE workload coming in, then it will basically give priority to the LSE. And then you have LS, so latency sensitive. So here it's good. It's like a burstable, I would say, almost. So it's great. And then you have the last called BE batch. So you have in your name. So basically, it's for batch. It's basically best effort. So it's basically it's if they are here, they will get resources if there are resources available. So if we have to combine with the table that we had with guarantee, burstable, and best effort, LSR and LS are basically guaranteed, and LSE is basically the top. And then you have the BE. And of course, I didn't touch base on the fifth one, system. System is basically everything that is used for Kubernetes or kubeproxy, kubedns, anything that is critical from the operation side of the cluster. Will you can assign the system KOS, and they are basically the top higher priority, because we want to make sure that if you have a new node, those components are running before any LSE KOS. So that's pretty much the idea. All right. So what I've decided to do, and you're going to help me for that, because I decided to take the OpenTelemetry demo applications. I've prepared a Helm chart. So I took the Helm chart from the OpenTelemetry demo, and then I said, okay, what I want is to assign some quality pod priority classes to those components. We're going to deploy it, and then we're going to watch the different things and and play with the resources. So that's going to be the exercise for today, and then we can move on to the pod groups and other things that comes with a coordinator. And especially, there is one thing that I didn't mention is the cluster profile, because at the end, one of the coordlet is profiling. So not profiling, but is reporting a lot of metrics. So you can basically customize and apply some default policies to workload based on the labels. So which is quite interesting. So you don't have to put directly the annotations or the label directly on your code. So let's grab those stuff here, put it here, and then let's assign. So what I want here is everything which is considered as front. I'm going to put LSE. So here I'll put it later up. So the front end proxy, because it's going to be then the front end, then the one of the component that are critical, that is heavily called by everything, is the product catalog. And then that's pretty much it. And then we're going to take the LSR, the second one, we're going to put it on the other component. So checkout. Then we have the add. Add is less important, but currency, because it's visible. And then I would mark as backend, for example, cart and everything. Yeah, basically that's going to be the idea. So here we're going to put LSRs here for recommendations. But at the end, what I have here is exactly this. So put it here. Let me know if you don't see pretty much. So I have this. I took the Helm charts from the OpenTelemetry demo, and then I said, okay, so I'm going to add some default annotations and everything, and I'm going through the components. So you can see the accounting, the ads, and what I did, I said, okay, I'm going to add those specific QA class, and for this you need to add this annotation. So here you can see it's LS. This one will be LS as well. And I have marked it as different category, and you'll see that this custom label here, you'll see that it will be introduced by another component. I will come back to it very briefly. So you can see here we have a backend latency sensitive, so LS latency sensitive, and then I did also the backend with LS, LSR for backend critical, for example, checkout, currency with something. So I did place all those annotations beforehand, so then I don't have to do it because it's going to be very boring for you guys. So this is done. Now you can see that there are a couple of different annotations that I have put in place here, like the policy and everything. And that comes me to the things that I need to deploy beforehand. I defined first this notion of SLO. And for this, I use what we called the collocation strategy. So it's a feature that you can enable. So in my case, I enabled all the feature flags from the project. And here it says we enabling this, and then here it's basically says how it's going to pull the metrics every 5-10 seconds. And here it says if the CPU is over 65%, or the memory is over 65%, then it will take actions to do some throttling. So this is basically how this gonna be. The triggering will be happening. Then you have the QoS. So here we define the actual SLO. You can see I'm defining the various class. So you can see that we have here how is it? I'm looking for where is the name? Here we have the LSR class, and we can see that the identity from the C group has placed it on the level 2, so very high. And then we have the LS class, which is at the same level. And here you can see that it's going to be minimum min limit percentage is that it's not going to be throttled. So I'm trying to
Uh,
put yeah.
Henrik, could you please zoom in? There is a request. Maybe if you could zoom in a bit more.
Yeah. So here I have a parameter that says how I can control how the throttling will be happening. So here it says 100%, and you can see that with the LS class, which is even if it's a C group here, I said the chance of being throttled will be 0. So there's some chance of be throttling, and then if you look at the BE, which is best effort, here it's more precise. You can see there's this notion of throttling 0%. Here it says so memory limits. It says how many allocations or the blocks will be for me. But here I'm saying throttling 80%. Here which means this type of class will be throttled in a higher class. So at the end, you can, with this approach, with this config map, you can customize and then fine tune how each of those class, how the resource allocations and resource behavior will happen in the cluster, which is pretty deep, and you can control, which is amazing. So this is basically the resource QoS. So by defining the QoS, this is what will happen. Second thing is you see here we have this notion of burstable, and you can see that I'm enabling the burstable, and there's a policy that you set by default. And here it says here how much the workload that has CPU burst flagged could consume more. So let's say I'm have a limit, but have a request. Here it says that I can consume 10 times more than my request in terms of CPU. So basically, I'm bursting. I'm going over the request that I've authorized. Then you have these. You can do the same thing for the quota and the period. So that's basically the idea with this config map. So we'll have to deploy it beforehand. And the second thing we need to do is you can see that we had a couple of annotations that were not standardized in these Helm charts. There is this coordinator demo. Obviously, this is not standardized here. The operator is looking for those specific annotations. So that's why those will become with another resource that we will deploy in a few seconds, called called the cluster collocation profile. And you can see here we're defining in here it's based on a label selector. It will apply so the specific classes. So you can see here we got the chord mid in terms of priority class. The scheduler will be placed by our scheduler that we have in core, and then we are putting the right policies like auto whatever. So this is basically the how you can basically define some predefined profiles with the cluster collocation profile, and this will be matching based on those annotations. So at the end, with the annotation that I've placed, I am going to heritate from specific configuration from the scheduler of Koordinator. So that's technically what you're going to have behind the scenes. So meaning that we have a couple of files to deploy. We will have to deploy. Yeah, because I zoomed in up. I have to deploy the SLO and then online because then I'm using all those different configurations. And then once this is deployed, we will try to deploy the Open Telemetry. All right, let's go and try then. All right, here, my CLI. What I'm going to do, because I don't want to do stupid things. Oh, come on. Put it here. What happens? Nope. All right, so let's go ahead. Let's go ahead and start with okay, so let's start with the SLO. That's going to be the first one. Maybe you want to zoom in, so I'm going to try to zoom in. All right, you see it? Oh, yes. Oh, even worse. Is it good? Okay.
Maybe we can zoom in a bit more, slightly more.
Thing is,
Yeah, that should be better.
yeah, now I don't see what I'm typing. Okay. All right, so we are at collocated profile, and we're going to apply first the SLO config that is going to go in the coordinator system namespace. What resource config map SLO? What? Let me zoom out because it's very up. What is going on here? Okay, so it's being configured, but okay. It says is missing. Oh, okay, never mind. All right, so it's been created. At least I have all the config map created and updated. I took the update. So now, once we have this, let me zoom in. I'm going to apply the next resource. Okay, and now we need to deploy the first file, 01. What? I don't see the... Where is my... Oh, here. 01. Okay, so we applied those two configurations. Do the same with the 02. No, stupid. Configuring the batch. And then we have the last one is 03 is for a mix profile. Done. So that means that all the profiles exist, and meaning that I could install my OpenTelemetry demo. Oh gosh, what's going on here? Up? No, I don't see it. Okay. And we are going to get the Helm charts of the hotel demo first. Okay. And then we're going to do just an update in case. Yeah, a lot of Helm charts. And oh, by the way, I removed Prometheus, I removed Grafana, I removed OpenSearch. I already have a collector, which I have not deployed, by the way, which is something I forgot. So let me first deploy the collector, because otherwise they will be complaining. So it's on 02 operator, and we're first going to deploy the daemon set. All right, and then we have the stateful set. So those are collectors will be running because they will get the traces from the hotel demo. Oh, what? No resource found in the default namespace. That is weird. That is strange. I should have something. Let me check what's going on with the. All right, and let's check if there's some things that I did wrong. Oh, gosh. Don't see workers. No, there's no alert. So why don't we? Why don't have? Should have the collector running? What is going on? What? Oh, I know. I should have thought about this. I should have, if I do get DS desired and 0 because it's a scheduler problem, I forgot to apply the RBAC. So 02 operator and then RBAC. What? Oh, okay. Okay, and now let me remove my 2 CRD. Okay, and then same thing for stateful set. And I'm going to reply it. Okay, and then I was worried. All right, so now they are running. They are up and running, meaning that if I look at this SVC, the hotel collector SVC exists, and in my Helm charts, I'm referring to that collector. So all the hotel traces will go directly to this service. All right, now that we have this, so let me create a namespace for kubectl, create ns hotel demo. Okay, and then let me do I'm going to copy this piece. It will be faster. Up and then -n, and then the value files. It's in 02 hotel values here, and then we're going to do --wait, and let's put a time timeout in case I did something wrong, which I hope I did not. Two arguments. No. What I did. Expected at most. What the fuck are you doing? Okay, let's do it again. Or I'm going to Google to see if I didn't do a bad Helm command. Come on. Or let me open I have an existing stuff. Let me see. I should have it here. Oh, what's going on? What's going on? What is going on? Let me check if there's. You open this project. You should be good. So I don't get it. Oh, that's my mistake. Where is it? Control C. Just forgot to put the namespace. All right, here. Okay, hotel demo, values. All right. Additional property. Oh, no. Okay, so meaning if I go back, we're going to do in a different way, because if you look at, where is it? If you look at what's going on here. Oh, shit. If you look at the docs, we are supposed to put the QoS, the scheduler, in where is it, as label. So the priority class, we can put it on the pod, but I was thinking more about, is it in my case, where was it? Collocation, no, it was in the resource reservation, no. Coordinate, no. Where's the annotations? An example. There was a section with a CPU. Is it here? No. Collocation Spark basement, no collection. It was somewhere here. Fine-grained CPU orchestrations. No. No. It was what? User manual. No. Here. Should be here. No. Okay. So okay, so let's install without the patch. That's the our changes. I'm gonna do a very quick. Where's the edit the IDE? Oh, come on. Where's my ID? Come on. What's going on? Okay, let me. Okay, I got it. All right, so let's go back and bring this up. I'm gonna duplicate this one. All right, and let's remove what he doesn't like. Shit. All right, let's do it very simple. He was complaining about what? Additional property. Wait, additional property is not allowed. Is not allowed. So he's complaining with the additional labels. All right, so let's put this. Let's remove all the labels that I've added very quickly, so then I can redeploy it. At least we will have the QoS, the QoS class defined. But the labels would have selected our profile, so that would apply some extra rules, which is a bummer to not be able to apply it. So I will try to do a patch on few deployments just to illustrate that, because otherwise it will be a way of demoing this really quickly. So be patient. I'm always a half there. What I wanted to avoid by preparing this is happening. All right. Again, let's remove this. All right. Now, say we have this. Let's do it again. Additional property, additional labels. What? But it was removed. Okay. And then the component, I think I did something wrong. If I need to check the components should be there. Am I good or not? Because it doesn't. Yes. Same level. Same level. Let's remove this. So then we don't have that. And then Let me save it in case. Installation failed. Additional property of is not allowed. Oh, too bad. Let me open it. Let me open just briefly the hotel demo hem charts to make it sure. Okay. Oh, wrong. Yes, that's the one. Default. Oh, it's under default. And that should be good. All right. And what do we have? Oh. Okay. And then components is a new component. Okay. Okay. And can I add? No way of adding additional labels. That's a bummer. Okay. Now that we have this, let's try. Additional property on is not allowed. Ah, we're getting to something. Oh, I'm looking at time. I spend a lot of time for covering things that are not really interesting, so I'm sorry. Now that we have this, come on. Let's take another here. Container conf. Oh, sorry. I have a yeah. I will have to debug that later on. But pods and then hotel demo. It's creating. Let's check. Yeah, it's taking I removed the restrictions on the other components, so I have a lot of components I don't need. And if I describe so let's check. So we have the annotation QS class. And let's check that if we have some logs on the coordinator on the device, which cube, let's put a dash o wide so then we can check on one of the device. Let's take, it's almost the same one. So let's describe this device. There's nothing. The good question I have is how do you check that? How do you check that the scheduler is actually taking this scheduling? Let's go to the coordinator system namespace and check the logs of the scheduler. Ah. So no. have nothing. See, updated event. You see here. So he scheduled those species. So now we know that he is looking at that. So he was responsible of deploying the hotel update event. He did it. And then let's check the other one. If there's maybe, I think it was 2 replica. So yes, it's been done, but I would be interesting to fail to acquire user probe. Oh, failed to acquire leads. Okay. So we have lots of things going on here. No. Okay. Has not yet expired. Okay. Let's go back to the hotel demo, but I wanted to figure out how I can see. It seems I was taken by the scheduler, but so I have 8 minutes left. I want to describe if I get the deploy. Do I have something about the scheduler? Let's take this one, for example, currency. All right, what do we have? Deployment controller scale, dot. Okay, so let's try to what I was going to say. Let's try to let me bring one of the labels that we had in the initial Helm charts. Let's take those 2 labels. I'm going to copy them. And let's modify, let's say, that's going to be, let's say, the checkout. Edit, deploy. All right. And here I'm going to add new labels. Oh, no, it's going to be on the pod, sorry. New labels. Up. To see if it's going to pick it up. And I'm wondering if it's not unclear for me. Let me check. Where is the docs? Let me search up. If there's a search button, so let me search. Annotation, scheduler. Great. Scheduler. Okay. Annotation. Use annotation to enable pod annotation. Oh, sorry. Okay. He was on. I saw it. Resource model. No. Priority. No. Yeah, that's the job. Okay, there's nothing. I was wondering if I need to put the annotations to say scheduler name, and I don't see it. Okay, so let's go back to the terminal and try to put those two things. Maybe adding also like another one on the CPU burst. Let's say I'm going to take this one. Oh, where's the terminal? Like, oh, here. Annotations. Come on. We have 4 minutes to go. Let's try that. All right, and see. Let's check the pods. Now it's been running. So now oh, I know. Maybe we can check. I put what was the change that I did? I put. Oh. Let's check the scribe. No. I did put, what was the name? It was backend critical. Backend critical and latency sensitive reserved. And those were the cluster policy, backend, and like maybe I can check if there's an event on the subject. No, which one? Backend. Best effort, no. That should be the one. Latency sensitive. Okay, so let's figure out the one. I think it should be okay, backend workload to see if there's something. There's no events on that. If I do get events, maybe. No, no, no.
Could you zoom in, Henrik? Possible. Thank you.
Looking if there's. I don't have any fail to create. I don't have the any. I just want to confirm that. Oh, yeah, that it has been handled by the coordinator scheduler. I cannot confirm it, so that's my concern. So otherwise, I'm looking at the time. So we have 1 minute to go. There's another concept that is available. So I didn't, for some reason, I'm not able to control it. I'm because I can see the pod is running, but I don't have confirmation that it's been scheduled by the actual scheduler. So that's kind of a limitation. We have the annotations in place, but I want to make sure that it's been actually handled by the scheduler, and I have no idea how to control it. If you know, please help us and drop a comment. Otherwise, there's something I wanted to talk about that could make sense. There's this notion of a pod group that let me check if I have an example that I've prepared. Gang scheduling here. Up. Where's put the IDE? So the if I zoom in for you, so the coordinator add this notion of pod group, and this is, for example, you have a workload and you only wants to have it scheduled if it has the right number of replica. So here I have a pod group called analytics job group. And then I have here, let's say on the hotel demo namespace, I have a, oh, maybe that's the stuff missing. Let me, I'm just curious. I'm going to just try to add this scheduler name into the checkout to see if it's picking up. But before we go jump, so here I'm going to do pod name, and I'm going to deploy it on the. You can see here there's only one pod, and then we're going to put 3 replica. So we'll start with one, and then we will deploy put the deployments, and the deployments will reach the actual number. So this pod will be pending until we have the right number of replica deployed. So this is the idea of a pod group, where you can put you can allocate to a group like a minimum resources. So it makes sense if, for example, you have some pods that are some given dependencies, and you're assigning to as a label the specific group that you have. So it could be also a smart way. But before we do this, I want to make sure. I'm sorry, but it just irritates me to not confirm that our deployment is actually doing what is. So let's do the edit on the checkout again, and I'm going to add in the I'm going to add in the spec of the container. Edit cancel. What? Why? What? Okay, let's do it that way. Let's deploy our example, because we will be able to confirm this theory that I have. So what I'm going to do is I'm going to remove from this example the replica, this one, where we're supposed to have in the same analytics job group. So if we don't have this one, then at the end, I'm going to remove it here. If we don't have this one, then the first part will be blocked. All right. So let's. I need to zoom out because it's very hard to. Okay. And then here, so it's the folder number 9. Oh. Okay, and okay, and now if we were in the hotel demo, technically, and our pod was named analytics driver. Where is the analytics driver? Ah, here. It's pending. You can see here it's currently pending. And now if I go back and I add this deployment and reapply. All right, and let's check the pods. And you can see that now everything is scheduled. So it's again another feature that Koordinator is getting. So this notion of groups, and you can even put group like a gang. So gang made of several groups. So you can create 2 groups, and then you can create a pod that belongs to the 2 groups. And then if the if all the requirements for both groups is not there, then it won't be deployed. So it's a way of putting this dependency approach of scheduling with the help of a coordinator. I think we reached the top of the hour, so I didn't cover everything that I wanted to touch base. And again, for me, I think the project is super interesting. To be clearly from what I've seen, I need to. I want really want to have this running. To be honest, this could be an amazing example. So I'm gonna probably not use the Helm charts, but use like a export the manifest. I have a version on another repo, and I will put those annotations. And I really want to apply some load, and then figure out if the load balancer is the load generator in that case is considered as a best effort. So if I start putting pressure on the OpenTelemetry demo, I may have the B, so the best effort parts that will be evicted, or at least the resource will be they will have more chance to be throttled, and looking at the graphs to confirm that. But at the end, I don't know. I mean, I tried to explain something that could where we can spend more hours, because there's so many things that it provides. They provide a really more advanced scheduling, more advanced descheduler, and also looking at they have a lot of metrics. I didn't touch base on that. I wanted to scrape that with a collector. That's why I started to deploy the collector. But there's a lot of areas to dig in more. But I think it's very interesting. I mean, at least it provides more a smarter way of sharing resources across the cluster compared to what we have by default. I mean, by default it's just amazing, but if you wants to more share, have a way of having resource allocated and reserved for specific workload, here they have those type of CRDs for that. So it sounds very interesting. I don't know if you have questions, Sive.
Yeah, I don't think so. I see any questions in the chat. Um, we'll probably give like a minute or two. If anyone has any questions for Henrik, please feel free to drop them in the chat.
So what I would
Uh,
do is I will try to go because I prepared the repo, but I don't wanted to test it live, which you can see was a big failure. So what I would try to do when if I have some time, spare time in the next coming days, I will try to clean up that repo and put all the working examples. And I really want to put this hotel demo story in place, and I will put it on GitHub on my own account. So if you search, if you want to get it, where is the okay, because it's we have to zoom in. If you want to get to my personal repo, you search for Henrik Rexed, and I will try to push it there. Maybe it could be also an excuse to be to do an episode about this project on my channel. Here, so try to monitor that folder, and I will try to put it there if you want to play around and try it out by yourself. I have a few examples to be inspired, and then use it on your environments. I will try to share it as soon as possible. So any other questions or any thoughts, any regards? Did you if you had the answers that the scheduler was taking it directly, let me know, because I was trying to control it and I didn't have. But Chive, by the way, do you have a way of checking that the schedule, who was responsible for the scheduling?
we might have to check that. Maybe like Audra might be. We can reach out to her.
Yeah, no, for in Kubernetes, if you have
Oh,
a
sorry.
yeah,
Sorry,
yeah.
what is the
If you
question?
have like a two scheduler, in that case, we have a two scheduler. So normally, because of the annotation that we added, the scheduler responsible was supposed to be coordinator, but I wanted to verify it, and I didn't get.
Oh, okay, okay.
I wanted to figure out. There's probably a way, a smarter way.
Yeah,
I will try to dig in on this.
sure.
All right.
All right. So it doesn't look like that we have any other questions. But again, thank you so much, Henrik. It is a wonderful overview, and I really love the diagrams that you showed throughout the entire session. I think like it is very well focused on diving into the architecture. Uh, but yeah, thank you so much for taking out the time, and thanks everyone for joining into the latest episode of the Chat Loop Back Off. We enjoyed the interaction and the questions from the audience. So thanks for joining us today, and we hope to see you again very soon.
See you.
All right, see you.
Bye.